The source code here, we can see an example of where we can change the order in which the tests are done to make the common case faster. This source code is typical when we read one input character at a time and do something. So the first we do is to check if we have if we have come to end of file. If not, we check have we reached the end of a line, and if not, have we reached a space character, and finally we do something. But this is really a bad order. If end of file, that's typically it's very infrequent. It happens at most once in the code. Here at exactly once, unless the program is terminated in some other way before. Okay, and a new line, that's typically not the most frequent character, and not space either. So we should not check them in this order. All these tests fail, and we should test for this first. So we can change it to this instead. We come to this else statement if in two situations: either that C is greater than a space character, or that C is not equal to the other characters that we check. So now we do it in the proper order. First check this, and then space, then new line, and lastly end of file. And if it's not end of file, then we do Z as well. If these statements are, for instance, incrementing a counter, then it's fine to duplicate this. I mean, it won't hurt, but it's really annoying and feels bad to have the same code in two cases. So it would be better to put them in separate functions and let the compiler inline them, which it is very good at. But this is just a generic statement that does something. Okay. If they are, if Z is too big, then we don't want to duplicate it. Okay, so we could use function call in both situations, or we can do this, but that is beyond painfulness. It really is not pretty to have a goto into the middle of an if statement. Okay. We may ask ourselves, can the compiler not do this automatically? Well, in principle it could, but then it needs some extra information about the frequency of different input characters. So suppose it does not know that, and if we instead use a compiler flag to collect statistics about the execution and branches, then that can be reused if we run. First we compile to produce the statistics, run the program, and then recompile it with the collected statistics. You will see that in the last lab. But at least this year, GCC does not do that optimization. There was published some years ago an article about doing this, so at least one compiler does it, but it's not GCC. If we actually I tested, and if this is the machine code for recompiling with the statistics, and what we can see here is that it compares against compare word immediate, and it register 3, which contains the variable this 3. is it contains the variable c, and it compares against -1, which is end of file, and then it compares against new line, and then it compares against space. Now this 0, 5 and 7, if you recall from the lecture about the power architecture, there are 8 4-bit fields which contain the result of comparisons. So this 0, 5 and 7 indicate which such field should be written. But what is interesting here is that the first branch it does is branch equal with this field, which contains the value of whether C was equal to end of file. Okay, so it starts with comparing against end of file. And we can see it has a minus here, and that minus is the compiler's way of telling the processor that it probably won't take this branch. So it's a hint to the CPU that it probably not likely that this branch will be taken, which corresponds to the statistics that it collected. And then the next branch not equal for 5, which compared against the new line. Okay, it's likely that it's not equal to new line. Okay, and then it does some more things. But what the point of this is that GCC does not reorder the way the branches, I mean the branches are taken or evaluated. That these comparisons are done in this order doesn't matter, because the pipeline can perform all of this in the same clock cycle. Okay.